Okay, so what I want you to do is pause the video here, try to do these four problems on your own on the grid provided. You can do them all together, and then play the video to check if your answer matches the answer that you should have. Okay, so hopefully your graphs look very similar. I color coded them so you can easily see which one is which. And I also answered questions about the domain and range. The most difficult part is recognizing what the transformation is, and then once you realize what transformation is being done, then you can correctly graph the graph. Okay, so here's another example for us where we have a parent graph that is going to be shifted horizontally because of this minus 4, and when you shift horizontally, if it's minus 4, you actually shift to the right 4. So this is a horizontal shift, or horizontal translation. I'm going to be consistent, so we'll use word translation again. Translation, right 4. So what I'm going to do is I'm going to graph our parent graph just to have it in front of us. 9, 3. And then we're going to take every point and we're going to move it to the right 4. So I take this point and I move it to the right 4. I take this point and move it to the right 4. I take this point and move it to the right 4. And I take this point and move it to the right 4. And when you move your graph, if you just shifted right, left, up, down, it should have exactly the same shape. So it looks good. Our domain is going to be x is greater than or equal to 4 because our smallest x value that we have here is 4. And then our range is going to be y is greater than or equal to 0 because for the y values we have 0 and everything above it. In this example we have 3 things going on, so we have to be very careful about the order when we start graphing it. And we're going to follow order operations. So first we do everything that deals with multiplication. So first we're going to address this 2. This is going to be a vertical stretch of 2. Then we have a horizontal translation left 4. And then we have a vertical translation down 1. Okay, so when something like this happens, it's usually good to graph it in sort of chunks. So first, I'm going to graph, or at least plot the dots for the parent graph, which is going to be this. Then I'm going to worry about my vertical stretch. So I'll do it in red. And it's not, I'm going to use crosses again because it's not a final graph. I'm just using it as an in-between point. So everything is going to be twice as far. So this one was 1 unit away, now it's 2 units away. This point was 2 units away, now it's 4 units away. This point was 3 units away, now it's 6 points away. And then I can move it left 4, and I actually don't have a grid here. And we'll just have to improvise. So what we're going to do is we're going to take all this, shift it a little bit. Alright, so I just switched my grid, and you're going to have the same ones. The points don't change. They're still going to be at the dots where we left them. So let me just fix this really quick. Okay, so it was at 9, 3, and then we said it was going to be at 9, 6, because it's twice as far. Then what I'm going to do is move it left 4. So I'm going to take now my red ones, because that's the stretch. Move it left 4. 1, 2, 3, 4. Take this one, move it left 4, which takes me here. Take this one, move it left 4, which takes me here. And then my green one is going to be my actual final graph after I move everything down 1. So I take my last set of points and move it down 1. And this is going to be my final graph because this is what we get after we stretch it vertically by 2, move it left 4, and move it down 1. So the green is going to be our actual final graph for y is equal to 2 square root of x plus 4 minus 1. Okay, so go ahead and pause the video, try to graph number 5 and try to identify a domain or range for the example we just done, then play the video to see if you answered it correctly. Alright, so here are the answers. Double check, and if you didn't get something, you might want to go back and replay one of the examples. The green is the answer to domain and range for example 5, and in red, here we have our graph, which is a horizontal translation left 3. Alright, so here's our last example. We're going to apply what we learned to a real-world situation. So this problem deals with microphone sales, and it says that for the period from 1988 to 2002, the amount of sales, Y, which is measured in millions of dollars, of microphones in the United States can be modeled by the function y equals 93 square root of x plus 2.2. So this is our graph here. Okay. So they're asking us, in what year were the microphone sales about 325 million? So what we're going to do is we're going to go on the y-axis because the sales in millions are represented by y, and we're going to go to our graph to see what point has that y value, and here where we have the dot, and we're going to go back, go down and read the year or the x value. So what this tells us is that the microphone sales are about 325 million when x is 10. Now it's not year 10, we actually have to think about what this means. So we were told that x is the number of years since 1988. So then when x is 10, that means it's 10 years after 1988, so our year is actually 1998. And that's our answer. So now you have to use the same graph to answer another question, and then pause the video, do the problem, so then you could self-check and see whether you understood it. Alright, so if you did it correctly, you should also get the same answer as me, and if not, go back and re-listen to example number 6, and hopefully it makes more sense. And this was our last example, and this is the end of lesson 11.1 on graphing radical functions, square root functions.